track of landing accidents. Are you ready? Yeah.
Should I connect to the projector?
Yeah, you can do that.
So I have HDMI.
So just plug yourself. Yep, it should work. Change the source projector.
You probably know this better than I do.
Cool, it's you.
Okay.
Looks good.
It looks like it does. Almost the same.
It seems a bit out of ratio.
Like just minimize. Let's do it for right now. Kanske inte problem med att se ställena och där så kan det så att oj. Ser du där? Well, that's visible enough. Yeah, I think it's fine. Okay. So basically what we've done so far is having a couple of meetings, discussing technology, making some choices, and we've started working on some user interface prototypes where each and every one of us have basically started playing with the technology we have chosen, and we're going to show two of those prototypes today, or like showing that we started to throw some ideas around.
Well, we have chosen to run in the background Node.js and the front end React for the UI part, and we also decided that we will have a service, backend service which we will access our RESTful API, which is also running with Node. But we haven't done anything for the backend service, just the UI, so we can present something, show the customer, and that he can give us some feedback how he wants to look at. We have started creating some issues on Jira and also our daily Scrum page in Confluence. And yeah, that's basically it then.
So can you say one more thing about we decided to solve the sprint planning meetings by having a new page every day on Confluence, so everyone can like type a short description and like tag the issues they're working on. So that seems to be working all right, because it's hard to like cooperate with 5 people, getting them to speak daily, and it's just a place to say or give some thought to what you did yesterday and what you're going to do today. That seems to be working. So the prototypes, this is my example, where I've just done some basic random some information to display. It's all used hard-coded data so far, because it's a prototype, pretty much. The second one I want to show was this one, a bit more graphical, and I think it's much nicer than just a table, because the old one, or the other one I showed, is much more similar to the current solution, which we kind of want to move away from.
It's just basic stuff. It's, for example, here are just images, but I want to get it done that if you, for example, type a place where the accident is happening, that the background service is accessing Google Maps and taking a screenshot and making the, so there will be a thumbnail another map itself, but with a link behind to map to the Google Map location or something like this. But it wasn't possible in 1 week. And also to look out, if you click on browse accidents, that's not programmed by myself, that's from other, that we have something like a heat map of Norway where the accidents are located, and there you can see where a lot of accidents are happening or something like this.
And thoughts on what we could do better? First and foremost, we could have, or we would like to be more organized in terms of when to have meetings, because we have like really last minute decisions on when to meet, because it's kind of hard, or we had some trouble in the beginning to have all 5 people show up at the same time because of different lecture dates, work, family, etc. So that's something we want to improve on, like have one specific date for meetings and stuff.
Also, like during the meetings where we didn't have much progress, we used a lot of time to make quite a few decisions, and we think that's because we don't really have like a leading role there, so no one like took the initiative almost at all. So what could have been done maybe in an hour took 3 hours for us. In the couple of meetings we've had, we need to improve on that as well. Yeah. Anything else?
No, I think that's good.
Can we see on Jira your issues and your one-line chart for this sprint?
So it's our current sprint.
Okay.
It's a lot of research for now. We haven't really had too much time developing because there's a lot of new things for many of our members in the development team.
So did you finish what you planned for this sprint?
Not everything. But I think we kind of used it wrongly as well, because we used pretty much pulled everything we made inside there,
Okay.
because we didn't have like the sprint planning meeting ahead, so we kind of did it underway the sprint.
Okay, so whatever you decided, you put everything in the sprint one without thinking whether you'll be able to finish or not.
Pretty much.
For this sprint, yes.
So that is also one thing you need to
Yeah, we should improve
So
that.
next time you need to little bit estimate and think what you can and you cannot do in 2 weeks. Or maybe you could have done that and your progress was not what you expected.
So our burnout chart is probably not good at all.
Yeah.
I would guess. I think I looked at it yesterday and it looked kind of horrible. Yeah.
Very informative.
It basically shows no progress in using work.
Yeah.
That's probably because we didn't, because of many of the custom issue types like research and things. Simon had to activate estimations for us because we couldn't literally estimate in the tool. So we didn't have that until late in the sprint, so we didn't get to estimate at all.
Okay.
So that's probably why it looks like that.
So that explains that flat and rise,
Yeah.
but why there is no drop.
Yeah.
Because we didn't have estimations, because we couldn't add it for some reason.
More likely that are you using story points or our
Story points.
story points? So if you never close any issues,
Yeah.
they won't be registered. So I guess you have all
You have to-
issues with all code.
Yeah.
So unless you close them, there won't be any drop down in the burner chart.
But the closed issues we had didn't have estimations.
If you close them?
We have some closed issues, but some of them didn't have estimations
Right.
either.
Yes.
So it won't show up at all.
That's right.
So the ones that are not closed yet.
That's right. So hopefully it will look better next time.
And yeah, we've seen
We've seen that before.
Every year we've seen charge like that. And we haven't seen, well, at the end of the course, they will look differently, I hope. So there are two parts of getting this to work properly. more realistic or more the way it is. That is number one, is to have short tasks. If you have tasks that take the whole sprint, obviously there won't be anything completed until the sprint. So if you have short tasks, then you complete more tasks, and then you will have a gradual decrease in the curve. The other thing is that you actually close when you're done.
Yes. You don't wait until the end. Yeah.
Because otherwise, I mean, if I, as the programmer or if the supervisor wants to have a look to see what's your progress, you just can't tell. It doesn't say anything. It just says that you're working. Hopefully, you're working, but haven't completed anything. So that's why it's nice to have that the step down. And I think if you have been using hours, I think, and you record hours, there will be a natural step down as you range for hours, because then you have the estimate, and you have extra work hours. And when you start points, you have to close them as early as possible to show a kind of progress. So that means that you need to have short tasks, and you need to complete them continuously.
Do you want us to show the conference, the sprint, or the daily meetings as well?
Sure. Yeah.
So basically we have this page that we set up, and we can easily add new daily scrums. Looks like this. This is our most recent one. That was yesterday, so not many members work because it's a Sunday pretty well. So it's going to be a more active day. Basically, just what did I do yesterday, if you did anything, or what you're going to do today, and like link to issues in Jira. So that's basically how we decide to solve it. Just making you one of these every day, pretty much.
I have two questions. Number one, did you try to get the system up and running, or that's not
We have decided we don't really need it because we are doing it pretty much from scratch. So it would be for us only a waste of time if we try to learn ASP and get into the code, which is also kind of, for me, it's mainly Norwegian and I'm English, so I need to translate nearly everything. And that's why this is that we have the database, we can transform the database to MongoDB or SQL or something like this and get the data out of it. But the UI we're doing pretty much on our, what we see is the actual page running anywhere, and it doesn't look good for us with the search and the drop downs and the stuff, so we do it pretty much everything on our own.
I don't disagree with that decision. I'm just thinking that if it didn't take too much effort, the advantage of having it up and running is that you will ease your communication with the customer, because you know exactly what he has today. Users say, no, I want something that's done before. Now you have a clue what you have before. So by getting it up and running, that will easy to do. Then you will be at the same level as the customer, because you know what the existing functionality is. So, but I feel really that you are the implement. So that's your choice. But just be aware that you may have some more harder time to understand, and might be more misunderstanding in communication with the customer if you don't know what is currently using and see.
Isn't it running on the website?
Not the management tools,
Okay.
just the search interface and the results. And most of the ASPs are management tools. But that's, of course, it's your decision, as you say, you're implementing the language, and it takes a lot of time just to get to know the technology that they're using. Just to say that there's potential possibility that, sure that when you communicate with customers that you're very clear that you haven't tested, so you need to explain everything from the scratch from the very beginning. The other kind of comment I was having is I don't know how you said that you are all getting the technology, which is a good thing. I hope you don't all do the same thing, that you are complementary. And what I would prefer is that now you just look at the client side. I would prefer that we have a rather less functionality, but look at the whole system. So you have a little bit of server working, a little bit of client working, so you have a kind of a through the whole technology stack, rather than just being at the client that maybe you are further understanding the client of the server, but the disadvantage is that you have no idea how much it will take the server, so it's hard for you how to estimate next sprint because you don't have, unless you have more in-depth understanding of the server side. So it might be an idea also when we come to the next, that goes for all teams. Try to find, when we do demos, try to find something that you can show from end to end rather than being very advanced on the data model or database side or the user interface side. Try to find something that will show all layers. Maybe you have, but that's it depends on everybody studying client side, for instance. That's what we've done.
That's what we want to do in this sprint, also back-end side. But for last sprint, it was just not much time enough to learn the new technology. For most of us, Node.js was new and React was new. So we decided we focus first on the front end because there we see something faster and the back-end stuff will come.
Your sprints are 2 weekly or weekly? How long are your sprints?
2 weeks.
Yeah. Anything else? No? No. Thank you.
Next team. Who's coming? Web-based education. Next time we will change the order so that us don't have to go first all the time. By the way, I forgot to ask how you are working with one of the remote students.
We're talking through right now from Discord. Yeah, I was chatting with them.
Okay, and is it working fine so far?
I think so.
You mentioned the problem is rather that we are finding that every one of us is time. Because the remote student is family and is only working about this.
Yeah.
So it's hard to find the way.
I think we need to keep him in the loop. But still, we need to get those things.
Yeah. This is what we got so far. We've been doing some prototypes, but we quickly agreed how the system would look. Pretty clean and easy. With just tabs on top. And you can just click next. Previous, yeah. But we've not implemented a lot of the actual testing courses yet. We're still having some discussion on how to solve that problem. And yeah, we've been having a lot of discussions on different things, and we have not been able to log everything, I think, on the
Not everything has been logged, but most of the hours, I believe.
Yeah.
And we also have experimented a bit with the login feature by using to simplify it by not having to store user passwords in the database and such. We will evaluate it, but we store the data in the database. So, yeah, login should work when I start handling the response. And as for Jira, here is the burn-down chart. This is work hours and hours spent. Not impressive, but I think some of the issues we forgot to create an estimate on. But yeah, chart looks bad.
And some of our issues were too big, I think. We had to, they were too general, so we weren't able to complete it in this sprint. So for the next sprint, we should try to divide it up more and make smaller issues out of the bigger ones. Yes, and we've been having daily Scrum meetings on Slack. And we have also met a couple of times a week and been sitting together and programming and learning a bit from each other, and also learning how to use Git or Bitbucket. So everyone is on the same page there.
Yeah, it's also been a challenge to get used to developing in with Angular, Node, Express, and yeah, MongoDB using the neem stack pattern for developing. Yeah, that's about it. I think.
Any lessons from the previous sprint? What you have done?
I think for the next sprint, we have to start right away. We're having a meeting after this seminar, and we'll try to create all the issues from start and really think hard about what we hope to accomplish the next sprint. And more.
Well, we'll have to try to get estimates on the time the issues will do better than last time. Since last time we created some issues during sprint 2, and that should perhaps have been thought about in the start before it actually started. Yeah, and one of the challenge was to actually divide the work well between the 4 members in the group, since in the beginning they only thought about starting on the front end, and that was a challenge since 4 members of the team on the front end there was too little work there, so we started a bit on the back end eventually to be able to get all members work.
Yeah, I think we have divided it better now between the 4 of us.
Yeah.
So that yeah, we don't actually work on the exact same thing as we did in the start.
Yeah.
And we had a problem with that where it was only for a couple of hours, but 2 of us were actually working on the exact same thing, and we had to just choose one of the solutions.
That's what I have seen so far. It seems the progress is not what we expected. Not only for your team, maybe for other teams it will be better, but so far it seems that this sprint was not utilized as much as we would like. And as Rumi suggested, instead of concentrating all on user interface side or something, it's better to take something where you have the whole thread you can show from front to the back end. Then I think maybe you'll be able to see your progress better in that case, because I think maybe you are underestimating your potential so far, because then in the end what will happen, you will have so many things to work on towards the end. It's better if you utilize your time from beginning better.
Could you put up the burner chart again?
Yes, absolutely.
A couple of questions. Number one, if I get it right, I think the work is 64 hours. Divided by 4, that should be 16 hours per person. And that's about half what we expect. So if 16 hours about per week, sometimes 2, that should be 30 hours per person.
Actually, it's done 12 weeks. It's 15 on team.
Yeah, okay.
Yeah.
Okay.
So 12 weeks in half.
So 24 rather than 16.
Yeah.
Sorry. I'm still on the round years. Yeah. My question there is, did you work on issues that are not recorded, or is this really the amount of time you spend? Because what we've seen before is that sometimes you don't make tasks for learning new technologies or investigating. That's the need that it's hard to see and it's hard to learn how much you will take. So that the question is this all the work or are there activities, tasks that you didn't log here?
I believe there's some meetings in the start where we didn't log all our hours.
Yeah, well, I'm used to decide this more
We created issues for all the different learning that we had to do.
very good.
But I think that at least I haven't logged some of them for some reason. I don't know. I think it shows most of the learning as well.
Yeah, I think that's good because we're gonna probably harassing you every sprint review if you don't have close to that expected number. So it's 24 times 4, so around 100 hours per sprint. That's kind of what we expect. The other question is, so the green line is about at the height of where the red starts, but the red hasn't really dropped much. So will that mean that you are not completed lots of tasks yet, or does it mean that you have failed terribly in estimating these tasks? So what's the explanation why the red didn't sink as much as the green has increased?
We don't have estimates for all the tasks, do we?
But still, there are 72 hours estimated. So what happened to from 72 hours estimate you are down
Yeah.
to 63, so you are about 9 or 10 hours after the estimate you have actually worked. And of the 72 hours that we did estimate, there are still 62 hours to do. And the question is that because it was much more work or because these tasks aren't completed yet?
Well, I think perhaps the problem is that we haven't closed these 4 issues in progress. That's
Yeah.
probably the main
Yeah,
contributor
try to
to
post and
that.
see how it changes. But you don't need to do it now, but do that, and then you see, because what you need to do after the sprint is to see, are we good in estimating? If you aren't, then you need to understand why the estimates are off and be better at estimating the next time.
And I think also that some of the issues to the left there that is not finished is they were too big. Like style the data flow testing page that should be divided into smaller issues so that we could actually complete them in the sprint, because that's more for the finished products where we can say that, okay, we have now completed the data flow testing part of the application.
The reason for me being part of it right now is that for you, this is a tool, project management tool, and that you already, this works as a project management tool right now, but it's also a very important communication tool to the rest of the market, to the supervisors, to the product owners, to the rest of the companies. If you work in the company, this will be what the project managers and the upper management will use to see how well you progress. And if there is no progress, everyone depends on what's happening. That's why it's important, not just for the team, but also for the outside world. And this reflects the actual state of the project.
have some improvements to do for the next sprint.
And we're done.
Yeah.
Yep.
Thank you.
Ja. Skal vi gå gjennom liksom, fra stillelsen til fronten på en måte?
So I guess should we just start with demo, or should we just start with like the whole story? Because there is stuff hasn't been going super well. We got the demo, but we have been having some issues in the startup. So, for instance, well, I guess we can take that once we actually get over to the Jira part. So we have now gotten a demo where we have set up Loopback on our local machines. So we all basically, to make development easier, we all run in like the same in VirtualBox dev image to make sure that everyone has the same environment. So we thought that that would help us improve because we don't have, or improve the workflow because we don't have different environments that creates problems for us. So we set up the Loopback API for the game lobby. Currently, it's just like all the default generated stuff that Loopback sets up for us. And we've created a demo where we just have our database running on our virtual machines, and then you go into Unity and start up a connection to a server by asking to get a match and get back the match with an IP address of the host and a port so that you can connect. And hopefully this will work if it hasn't changed any IP addresses or anything. Hopefully not. So that's one of the issues, is that we haven't got proper, or we haven't gotten to set ourselves up properly on the database yet, like on the actual server. So we're doing this on local testing, and that sort of gets in the way because suddenly someone changes or suddenly the IP address change on our virtual machine, and then the demo breaks. But as you can see, we can actually log on and start working or to start playing. So that's sort of like the demo of what we got. So it's functional. I guess that's the most important there. So we just send back JSON objects containing different fields. So in this case, our game called, or the match called chat test.
Yeah, so the first entry is the mock we used earlier.
Yeah.
And then we added a new one.
Yeah.
When hosting game.
Yeah. So we can then create matches, create it related to a certain game, and also like get all the matches and join a specific one. So the further plan for the next sprint is hopefully to get up and going on the actual server as soon as possible. Once we do that, we are thinking of just starting to hand out game tokens to the third graders so that they can start implementing this stuff into their games. And then we'll actually have users which can report on actual issues, etc. So that's sort of what we did get to do, but we did have several issues along the way. For instance, we got to meet up with Simon and had a talk with him about what we were actually supposed to make. That we were just supposed to make a generic game lobby, etc. We sat down and started making issues, or Jira crashed, so we started making issues on paper, which is also why there is no estimation for like the issues we created on paper. I never got around to put them in, which is just fine, considering that it turned out that we weren't supposed to or we were thinking of doing everything in C# or something, and it turned out that, hey, we already had different Node.js stuff installed on the server, and we were supposed to use those. So we found that out basically on Wednesday.
Yeah, we got all the technology finalized on Wednesday.
Yeah, then we knew what we're actually going to do this Wednesday. So that meant, and we were also having courses up in Trondheim and stuff, so we have a lot to do currently. So we set up the weekend to try and just do like a rapid sprint. So we tossed all the old issues out, and created a VirtualBox image which everyone could work with, and then just started doing tutorials. So we worked over the weekend to try and set everything up and understand sort of the basics of loopback. Additionally, we have not gotten to actually install this on the server yet, which then creates even more issues for us. But that's sort of where we are currently functionally in the process, which also means that all our Jira stuff, none of that actually makes any sense, because the estimation and stuff that we did was not related to the task that we actually ended up finishing. So we also have a nice straight line in our burnout chart.
Can you bring up the
Yeah.
Let's see that nice group.
Yeah.
This was the heart rate monitor. I don't think
Yeah.
it's very strange. Very fine.
Yeah, no, I mean nice horizontal one.
Yeah.
Yeah,
So
because
like,
Yeah, because we didn't like when we started with all the new technology, we didn't actually get around to estimating the stuff. We were just like, okay, I guess halfway through Saturday, we actually went, okay, now we sort of know a bit what we're doing, so let's just try to hack together the demo and get that up and going. And then we didn't take the time to do the time estimations.
and also Jira didn't really work when we started planning early on either. So
Yeah,
and we had one member that didn't have access to Jira. So
which he has apparently sent like 3 or 4 emails about.
Yeah.
So, yeah.
I got this yesterday, and we will make sure that these problems will be sorted.
Yeah.
So I think about the Jira, so what are the Jira issues?
No, it just crashed. Like suddenly we didn't get access to our issues pages anymore, and then we just got a lot of bad requests.
and we could
Etc.
do planning poker.
Yeah, we couldn't do the planning poker. So sort of, yeah, everything just suddenly
how
like.
long was that made? Did you try again like a couple hours later? Or?
Well, it went through the entire meeting, which was about 4 hours.
And it happened the day later as well, I think.
Yeah.
So it was for 2 days at the very least.
Is it still a problem?
No, it
No.
shouldn't work now.
It didn't start until an hour or so into the meeting, but then it was down until at least the day after for me.
Yeah.
We did do an update, but we did an update really early on, and we didn't see much activity with the update. So you may have just quit the update window.
Yeah.
And had cache issue with the update.
Yeah. Also, we had some issues regarding the semantic commits, which we were then trying to be using, that they didn't actually, stuff were registered as closed, so they were like moved to the end of the on the workboard. But we noticed that some of the issues were sort of crossed out, but others weren't. But they're still marked as closed, but they didn't like disappear from the
Well, did you come and talk to us about it?
well, that was yesterday. And we think, I think I know why. I think it's just that Jira doesn't like how if you split sort of like so we basically had our heading, which contained our issue number and the tag, and then we were closing 2 issues with 1 commit because they were closely related. And I don't think it liked that I put like the last issue that we were supposed to close at the end of the file, but I'm not sure. It's said on the description that it's just ignored text, so I should be able to put in whatever I want, but again, it's not that great documented, so yeah. So that's sort of where we are. Where the plan is, yeah, to get to start handing out sort of functionality to get users to start testing. We're also still trying to figure out what we're actually supposed to make. If we're making an actual logging system or just sort of list of servers system, which we talked about yesterday. Currently, it's just a list of
That's
servers.
the initial task. Is
Yeah.
networking and deal with the lobby on top.
Yeah. I'm still not sure what you actually mean by lobby. But we can take that later. So yeah, I guess that's the sort of.
We'll also start working on some administration and game developer tools in the web interface, so people can start adding their games and change games they have added.
Yeah.
So that we can log into the application front end and do stuff that way when we're gonna do changes to content rather than functionality.
Yeah.
And that will be starting this week too.
Yeah, that also means also we're sort of, I guess we're sort of splitting up now. So first everyone wanted to, we did all the tutorials on Move Back together just to make sure that everyone was on the same page about how the system actually works. And now we'll be sort of trying to split up a bit more, where people will be going on working on different functionality and specialize in different stuff, so that someone is working on like the web application, while others are continuing to fix the functionality within the sort of core database. Yeah. Which also means that now we're finally understanding what we're actually doing, we can set up proper issues that sort of make sense.
We can see that everything came together.
Yeah.
As a last minute, maybe on the weekend, because it doesn't seem like very thought out process.
Well, the original process was quite thought out.
But it goes out.
Yeah.
Everything went out.
Yeah.
So, I hope the next sprint will be better.
Yeah. We also
and
hope
you
that.
are now clear what you are doing.
Maybe.
80%, 70%. Not everything will be clear.
Yeah, we are more clear about where we're going from here. At least, I think. We'll do a more talk, or we'll do a deeper talk with Simon about what we're actually supposed to continue.
Because of course, as you said, you have many technological issues.
Yeah.
Jira went down and other things. But still, as a team, as you planned, it seems everything just put together.
Oh no, the first one was excellently put together and planned out.
Yeah.
Okay.
But that was with the wrong technology
Like,
and
yeah.
with the wrong idea of where we should begin.
Well, we have
Rather than talk about it.
we have some pictures from the whiteboard
Oh, yeah, no.
somewhere on my mobile, which shows that we were like drawing different API calls, thinking about what we needed to add to the different databases, etc. We can probably just
That is part of documenting your work process.
yeah.
It hasn't been added in.
I don't need
Yeah, no,
to
they-
but if you want to show, okay, I believe if
Yeah.
you say that.
But now that we actually know what we're doing, stuff seems to be getting up, and having the sort of virtual box and stuff that is a shared environment did actually help quite a lot, because now everyone is sort of on the same page.
So identifying those critical things that you need to sort out so you can build on top is probably something you have to take into account more when planning.
Yeah, no, we had the perfect time.
Yeah, but you based it on a critical element that turned out to be not as, you didn't put as much attention to it as you should have. So you basically wasted your time. So if you identify that this infrastructure is the most important decision you have to make, then you would have solved that first. And then don't plan on something that turned out not to be useful.
And we solved that. Because we talked to you, we said that, yeah, we actually solved that. We said to you guys that, hey, we're doing this in C# and we're going to set up that database. And then you were the guys who said, that's a bad idea because we already have the technology. And by that point, we had already planned on doing the C# because we got sort of the green light on that. So sorry, I'm not taking all the blame on that one.
That's not a blame.
Or not blame, but like, I mean, we actually had
there was
the,
some communication
yeah.
issues, right?
Yeah, because
Which
we never,
you need to, because you are the people who are going to deliver, right?
Yeah.
So maybe this time your teachers were the customers of product owner, but next time there will be somebody else also.
Yeah.
And the same kind of issue can again happen.
Yeah.
Right? And then you cannot say, I'm not going to take the blame.
No, I didn't
Because
mean,
customers can be of different types and they can talk in different languages and they have something in mind but saying something else.
yeah,
So you will not have this luxury of clearly saying what they want all the time.
yeah,
right?
that I misspoke. I didn't mean
No,
take the blame.
it's okay. It's okay. Whatever you are thinking, you should be able to say.
Yeah.
I'm not defending here. I'm just trying
Yeah.
you to visualize that there can be other scenario where the same thing can happen.
Yeah.
Because customer doesn't need to be all the time knowing everything.
Yeah, and that's
That's what.
yeah, and that's
so
what
it's
we
good
faced. So it's good that we face that issue because
Yes.
that's part of the
Yeah, so we are
project.
trying to give you a real scenario.
So what we're saying is that crashing here wasn't actually a negative thing because we learned a lot.
No.
Yeah, but
Yeah.
what was interesting is documenting
Yeah.
your process
Yeah.
allows you, when you come into a meeting like this,
Yeah.
allows you to show stuff and say, look, see, rather than, oh, yeah, we did it.
Yeah, no, we have the meetings proceedings.
Yeah.
It would have been on Jira too if it hadn't crashed
Yeah.
during the meeting.
So we have all the proceedings. They will be uploaded as soon as we sort of get the time to actually upload them.
Yeah, I don't buy into that Jira crash delivery project. I mean, you have
For the documentation?
work for 2 weeks and there are 0 tasks and 0.
There's not 0
No.
tasks. There's 17.
0 tasks estimated and worked on.
Yeah, and that's because we didn't update the issues after it crashed.
Right, but
And also
that's-
the ones that we-
I'm saying is that that's something that you continuously work on. You don't work on for one meeting, and if you crash in a meeting, you can do it. I mean,
No.
As I said it previously, we would like to see that the outage log has been solved, has been removed, but then there should be some pattern of the activities because this is for, as I said, this is for the environment, but it's also for you because next time when you're going to estimate,
Yeah.
now you're kind of hopefully have some mental ideas about what you spent time on, what you did, but you can't go back and see what actually happened. And so try to
Well, we have more.
try to make the estimates and keep logging on how much time you actually work on the various tasks as you do the working, and then you can show kind of the reports. And if there's a total redesign, okay, then in the middle there we have completely dropped down, and then you will see other tasks coming up, and there's a curve to explain, but now there is no life. That line says there's no life in this project, which is
So if I get to respond to that, basically the day that so we did a meeting about when we did the time estimations, when we're doing sort of the old technology, right? And that's when the Jira crashed. The day
what date was it?
that was the first Wednesday or first Tuesday, I think.
Tuesday or Wednesday last week.
Yeah, or not last week, but the first week in the sprint.
Yeah, the first.
And then it was sort of the Wednesday after that we started looking or talking about the different tools that sort of had to go some time to get more clarification on what tools we were actually using, which is also why we then didn't go and upload that all the old issues to Jira, because then we were sort of thinking, okay, are we going to sort of change the entire project? And that step took way too much time. Yeah. Which also means that we didn't want to go and add in all the old issues that we know now perhaps were incorrect.
So then if you have a task here to redesign the system, and you say it's going to take us 20 hours, then there will be some activity there, and you can build time on it. But you just work and slap together a demo, and you didn't record any of that. That's what
Well, we have our toggles, which we use to keep time to do time tracking.
That should be moved into is what we said.
Okay.
because this is
Can we integrate that, or do we have to do the commit sort of thing? Because that's quite error prone.
We're integration total. Oh, yeah.
So you don't have to believe us, you know.
No, we totally believe you. Only thing is that
We believe you. It's
Yeah.
believe you.
Well,
but
when
the
you
thing
say
is
that you don't
it's
buy
not
it,
apparent
that's
here.
yeah.
And if somebody else, some
Yeah.
other stakeholder will see
Yeah.
it, they will think that as a team there is nothing. Right? So we totally believe you. Don't think that we are not believing you, and you don't have to be defensive about that.
Yeah.
Right? We are not blaming, but this is just something learning.
Yeah.
We have done, which should not be repeated later.
No, we are now that so now that we have gotten our sort of
Lessons.
we are know where we're supposed to
what
go.
to do and
Yeah.
what not to do.
And we also know not to trust sort of the technology we're supposed to be using.
Okay.
Well, this is not a criticism, but in general, if one day out of 14 days the system is down, one day out of 14, I would still want to see the 30
Yeah.
days, they will still see some traces there. So if you rely everything's going to happen in one day, that's probably not the best.
Yeah, no, the stars sort of aligned for everything to breakdown there because I also went home to Kongsberg to try and sort of fix stuff at home. So there are like stuff just aligned the wrong way, and we obviously know that that's not optimal.
But in general, since this is the most important tool and this course is all about using methodologies, we need to know when these tools don't work. We need to know that we need to put a higher priority on getting these tools to be stable running.
Yeah.
So to tell us our issues. So this, I didn't know that we had these issues.
Yeah.
So Toggle is a tool to feed into Jira. There is no integration. You have to do it manually, but it's just a means to get something into Jira, right? So using Toggle to record your time, but at the end of those sessions, you have to link them to some issues here, right? So in Toggle, like when I work on a project, I actually say I'm working on this issue, right? And then you just transfer it back. You log time against the issues. If you happen to be working like in a block of 4 hours on Toggle, but you know you've been putting time into 3 issues, then you just split it in Jira. But that's a little bit of an administrative overhead you have to do manually. There is no easy way to do it. I try to log time with Jira only, but I don't like that. I'm not as organized to be able to always log time in Jira. So Toggle is much better tool for me to log time, and then you just do the transfer, right? And then sometimes it allows you to, like, if you worked on a block, say 4 hours on something, but it's not in Jira, then you say, okay, there should be an issue because I worked on it, right? So you then put that issue in. Changing issues in the sprint is not perfect, but you know, that's what we do. We do sprints and we learn how to be better planners and plan before the sprint starts. But in the first few sprints, don't expect that you will nail it perfectly. You will have issues which you didn't complete it, and you will have issues which are missing. So you basically need to deal with it during the sprint.
Okay, thank you.
Thank you.
Last week.
Do you need HDMI or VGA?
Yeah, I can use HDMI.
Or
I can use this. I can use this.
Okay.
Our project is about publication registry. So basically, we had to enhance a system that is already existing. So basically, the system consists on it's divided into events, and for each event you can like upload an essay, and at the end of the essay you can reference all the articles you have read in order to gather information to write your essay. And what we are supposed to do is to make links between the articles that the people have read and the essays that they have written in the system. So basically, we had the client side, the server side, and the database already working together, and we had to implement new features, especially for as I said, the links between the articles and the essays, but also as a user can add an article to the database, we had to add a feature that enables the system to search for the article in the database before adding it, in order to avoid double entries, duplicates. So this is the page where the user goes in to log a new article into the database. So basically, before our work, I would say,
we only add the button to add a new article and the list of the articles already existing in the database. And now we have, as you can see, added a dynamic search bar that allows us to search for an article in the database. So I think it's by title.
By title and author.
By title and author. So we start typing either the title or the author, and the list updates automatically, dynamically. And so this is the first feature we added to the system. The second one is during the addition of a new article. So it's it's kind of blurry, but we have 5 fields. We have author, title, published in, URL. So the URL is basically where we can find the article on the internet, and the year of publication. And we have a button, submit new article. And before submitting the article, the function that is called when we click on the button will first search in the database for the article, but this search is only by title. And if the article already exists in the database, well, so just click on it. So you see there is a Slack bar appearing saying article already exists, try again. So basically that's what we have.
Two articles with the same name.
Sorry?
What if there are 2 articles with the same name?
Yeah, we have
It's only
to.
by title now,
Yeah.
but we're also
We just have to check if both the author and the title are the same.
So yeah, for now it's only like basic.
There
It's
is still
working
a
only on the title.
possibility of this combination existing, but maybe in different year, then we need to check for year.
Yeah, that's true. Yeah.
There is a possibility that it is the extension of something and not reflected in the title by the same authors. But maybe in different year. I don't know how you are going to uniquely identify, but there is a possibility of this combination.
Actually,
Some books have like a second edition. It's the same book title,
okay.
same author, but it's the second edition.
Second edition. Okay, so we have to check
Yeah.
something else. Actually, I tried something this weekend, but it was kind of hard to make because in the construction of the loopback API, actually the article class, so the articles that are the way they are entered in the database, they have a field like a primary key named ID. So we could have tried to identify them with the ID, but the problem is that when we go to the page, add new article and try to submit the article, the data, we don't know the ID yet, and we cannot I tried to modify the model article and add the field ID. The problem is that as it's a primary key, when we try to push it into the database, well, it provokes an error because we can't push a primary key. So we'll have to work on it. But that's basically what we've done so far.
The next will be to add these features to the page where you create the essay. So there you have to attach an article to the essay. So we will integrate this function so you can choose a article that already exists, or you can attach a new article, which will look something like this.
We don't really see it, but yeah.
Well,
The entry fields are pretty washed out.
Concerning the Jira.
Yeah, the Jira. We have the dashboard. So our sprint lasted just 1 week. We had a pretty late meeting with Marius, and we didn't get the project before last weekend, I think.
Yeah, we really started working on it.
Yeah, and we didn't get the project running before before Wednesday or
Wednesday.
Thursday, I think.
I think on Wednesday
On
everything
Wednesday?
could work.
Yeah.
So we basically fixed everything on late Tuesday. So,
Yeah. So everything is done pretty late here. Yeah. Yeah, we used story points for estimate.
for So basically on the dashboard, what you can see that we have sometimes story points going like up again. It's because when we had some issues that we closed, and I think it's well, we reopened that we reopened them because we didn't notice that some some aspect of the feature actually didn't work, so we had to reopen the issue. So it's one of the things we have to enhance in our team, is that make sure that everything is perfectly working before closing the issue. So yeah, the reviewing phase, for example.
I think we also made a lot of issues before we actually got the system working, so we didn't really know like what we had to do with all the issues. So some were bigger and some were smaller than we initially thought.
That's it. Oh yeah, maybe do you have the big bucket opened? About the documentation. So basically we have the README, which is updated. I think you'll have to go to my branch because I didn't merge it with the master. Yeah, I haven't merged it yet, but so we have the README, which I try to update basically every day. So, well, this is only the prerequisites, but if you go like further down, so yeah, we have the main features. So this is basically what we have to do, like all the work. And then I added the to-do section, and I update it every time. So for example, now you can see that, yeah, about article existence checking. So if yeah, the file to modify. So I set it to done. I think it's the dynamic bar, the dynamic search bar done, and then this is kind of the work we have to do for the next sprint, but it's not complete yet. Try to keep track of everything we worked on so far.
The question is, go back to the webinar. As far as I can see, there are 23 story points and 14 story points that are not completed. Out of those 14, how far come have you started on them, or they are almost done and they are about to be complete, or how much effort do you think will be to complete the story points?
I think, yeah, those are the three. So basically, it's I think it's part of the of things we have to work on too, is to be less optimistic about the.
As we mentioned earlier, we created these issues last weekend, and we didn't get to work on them before Wednesday, Thursday.
So we didn't really know yet how the system already worked and how difficult it would be or not to realize that, to fix those issues. So we created them, as Benjamin said before, but then we realized that it will be kind of difficult to make them.
So is that to say that they haven't really started working on any of them. So
On those, not really. I mean, this one, yes.
This one?
Which one?
I think Sabina is working. Have been working on this one.
Oh yes, yes, yes.
Creating.
So some of the work is started.
and the other, if you go back to the burnout chart again, the shape of the burnout chart is, as we were some of this smiling here, is not very uncommon to see, especially at the beginning of these projects. That you see parts going up as well. As I said, the one reason could be that we closed something that wasn't really ready for closing. So that's something that we're going to talk about with testing and code review and all that, what we need to do to make sure that it's not prematurely closed. The other thing that may happen, and that will happen, and that we need to think about is that during your work, you find that there's something very important that you forgot about. And you want to do this in this round or this sprint. And in that case, if I don't know if that will happen to you, but to all of you, if that's the case, the recommended process is to then discuss with the product owner. Because if you find something that you didn't estimate that you want to do, or you think needs to be done, then there is something else that needs to be pushed back in the backlog because you can't do more than what you estimate. So if there's something new coming up, then you need to reduce the workload for the sprint by doing something out of the backlog. And you can't do that as a team without talking to the product owner. So there's something about that change of plan progress in which you find something is important, you need to deal with it, and it takes time. You need to find another task and push it back in the backlog because you can't do all of that in the sprint. So rather than you just adding on new tasks and having this increase during the project, I think it's better to have that negotiation with the owner when these things happen.
Is there anything else?
So what are you planning to improve? What is the lesson from the sprint that you want to change for the next one?
Make sure so we don't work on the same thing. Like, that also has to do a lot with the issues we made because we didn't know what's involved in each issue. So suddenly we were working on the same thing.
We have to get to know the smart commits. Yeah. We haven't been using those.
Yeah, we tried to make some, but they didn't work. When we did the smart commit, and then we went to Jira, and nothing had changed. So we have to see how maybe there is something we didn't do, like link the Jira to the big bucket or stuff. So yeah, we have to work on this too. And I think the communication is quite okay. Except sometimes we on Jira we assign issues to each other, but then we realize that we're working on the same thing, so we don't know if it's a problem of communication or if it's because actually we created two different issues that are actually the same, or maybe overlapping. Yeah, overlapping. So yeah, we have to work on this too. And the testing part, as you already said.
Yeah.
Okay. Thank
Well,
you.
thank you very much.
So, let's break and then we will start, right?
Yep.
Just before we go to break, one of the group asked me about adding additional issues, so the timing registry group, asked me to add like research and organization, and that you guys, you seem late to start to use those. My question was, does everybody want to use the same workflow as they are using, or use the workflow that they initially set up?
It would be cool to get like the research and organization, because it's hard to try and find out where you're actually supposed to be.
Yeah. So what we did is, and I'll just quickly show it. You guys can have a break if you're not like, if you already got the system, then you guys can go on. But I can plug in you where. Okay. So in Jira, also I'm seeing if I can buy the toggle integration. You guys want toggle integration? There's a toggle integrator, so but it says I have to ask them because we're a community license. So, oh, and we got the Bamboo license. We can also say that. Projects. Okay, so people are interested. So we have additional. Yep. So we have bug epic, new feature, non-functional change, organization, research, story, subtask, and task. So those were the ones you guys asked for. So I added those. And I haven't put icons for these two, but I found a research icon and I thought that'd be cute to put a research icon in. I see you guys noticed that and thought, oh, that's cute. Not necessary. Do you guys like that? Because I made that there for them. I can make special ones for you guys, right?
Non-functional change, organization, and research.
Those are the new ones I added.
That's not all of them, or the new feature, I think that wasn't that new? Or?
So new feature, yes. So new feature, that because you guys added it for feature, but new feature was something that is in Jira already. So I just used the one that exists in Jira rather than calling it feature. I called it new feature because that's what they already had. So yeah, so new feature is also new.
Okay. So
do you prefer that
possible,
scheme?
We would like the non-functional change, organization research, perhaps replace documentation.
Add a documentation task.
Yeah.
Right. So would everybody like a documentation task? Okay. So
for us, you can also just like, if it's less work for you, you can just give us the ones they have plus documentation, because if we'll just not use any that we aren't interested in using.
There is no harm in having.
There's no harm
in
adding something that you don't use. But so what I first do is we go to now.
But having too many makes it confusing, and sometimes you have two entries for the same thing.
Yeah, and people go, oh, I don't know which one to use because I've got too big a list. So
but you should obviously have the number what you need.
yeah, if you have the ones you need and you're clear about what they mean within your group, you you also have to know, and within your group have a process as to what we use to describe what we're doing, right? So that's why I have to show you guys before I actually change it for all of you.
Yeah, I was wondering what the actual task is, because technically everything is task.
Currently, everything goes in as tasks, yes.
No, I mean like there's a task category.
Yes.
That's basically everything, like all of the above.
Okay, so usually what companies do is, they put tasks under tasks, right? It's like, but if you want to specify what kind of task, and therefore have these different names for different tasks, then Jira allows you to do that, right? So it just defaults as, we just everything's a task, or just call it a task. And stories have tasks within them, and tasks can have subtasks. So that's the kind of, and epics can have stories and tasks and things, right? So that's the kind of default. We don't know anything about your project, so we're just going to call it a task because we don't know anything about what you're doing. But you can add new task names and make new workflows for those tasks, right? So blocking is one that sometimes is added, right? So you can, so you add to the columns of status, you can add blocking, where you can say something is now blocked, right? So it needs something resolved before it can go back in progress, right? So that's a status you can add. So it allows you to do those sort of things. So the question is, these guys wanted me to add these three, well, these four actually, I think is what you asked for. And so I added those four.
I think what's important here is to add up issue types that will help you to keep record of what you actually do and help you be better estimate next time. So
Yeah.
So that's why the number of types you see here might be very different from a company. So that's fine, because if that would be useful as a tool for you, that's what they added. And we can record and you can track of and both to communicate with us and to learn for yourself.
Yeah, because what I'm sort of uncertain about is I've looked through sort of like different descriptions, but they all seem like everything seems to be so general that you basically just make up your own descriptions anyway. So, for instance, I would say that it's like adding subtasks to me seems sort of that sort of depends on the situation. But should like a user story have subtasks, or should you just say that you are finishing a user story? Because if your user stories are small, then you don't actually need subtasks.
So the reason it starts off generic is because it's a generalized tool, right? And here is where I can go in and change those, right? So as a company, what we do is we make those decisions about what tasks should be called and what they should be described. And because it has, as you see here, this is the car Scrum issue type scheme. So it creates a type scheme per project, right? So you don't have to use the default. You can go with the default and then add stuff to it, or you can share each other's. The workflow I gave you was the bachelor workflow, but because I created all this, I now have a workflow that, because you guys also asked for blocked, I think. Yeah. So we created a workflow that had all of those issue types, and then in the actual, I thought I changed the workflow.
Does that also mean that you can change some of the statuses so that stuff can actually have priority, low, medium, high instead of blocker, which doesn't make sense for priority because that's not how it works for this. It's just what it's doing now.
So priority is different to status. So we can change what status it is. The priorities names, I don't know if I might be able to go and change those as well. Yeah. So I thought I had already done this step, but I'm going to associate with the applied computer science workflow. Did that just work? Okay. No, it didn't. What scheme used as workflow is what? Because I thought I had updated your workflow to include blocked as a. I couldn't bring it. Okay. That's annoying because I did actually have a new workflow, but where did the workflow go? So we can change these things, but if you guys are interested, then we can change it for your project, or we can make them all uniform, right? If you're all interested in having at least that set of additional 4, then I can update you to all having those ones.
Also, you have to merge, if you're working on different branch, you have to merge it with master until the issues are actually closed. Because now we have an issue that we have marked as closed, and it says here that the status is closed, but it still shows up on the list of open issues.
We'll have to look into that.
That is in the branch or in the...
It's still in the branch. But it sort of seems weird that it's marked as closed, but it's still in open issues.
So, yeah, the workflows, I thought
there might be some glitches with Jira integration. So, we had to close some issues manually because there's nothing.
We do also have, if you're interested, we have command line integration for Git set up. So if you guys want to use command line, you can download the command line integration tool and command line into Jira and do everything in Git Bash and do command line and never have to touch the GUI, if that's your preference. So yeah, we also have that tool. Where are my workflows? Add workflow.
Does that mean you install in that machine?
Yeah, so we've got it installed on the so that was the one I had designed. Yeah, so we've got it installed on the server.
So you need SSH or?
So yes, I think you need to use SSH and use an agent, use your SSH key and set those things up. But I do that if you're using Git Bash anyway. You need to do that to Bitbucket. So it just gives an OAuth into Jira, and then you just have command line. You can open and close issues and create new issues, and it's actually intended for basically large companies who want to do
Automation.
Automate,
Scripting.
create 100 repository, like create 100 projects, do all of the do this to every one of those projects, add these issues to all of these projects. So so this was the workflow I had intended to add you. I don't know if you guys got this with blocked, but that is the workflow, normal workflow plus blocked. And then, in here, when I have, I name that block, which is what you get in the drop down, right? So the names here are what appears in the GUI, right? So this is all integrated. But how do I go next? And I associate all of those and go finish. Go publish. Right. And now I can go associate. So it's going through your project and now reattaching those to a workflow. Knowledge. So now when I go, so you've got these are the issues, and when I go to boards, so boards, no, I have to go back to the project itself. Figure. And blocked. See, blocked is not attached. So what I can do is I add a column. Do you guys want me to add a column called blocked?
Yes.
And so I add a column called blocked. I put the blocked issue in there, and then I can. And then that's done, which means now when you go to your general and you go, if I go back to board, you'll now see that there is in their board sprint 1, active sprints, blocked.
Nice. Thanks very much.
Okay, so that's the process for adding a new column, and because I had added the status type earlier, I can now add it to the column and stuff. So yeah, so that's it also means that when you're in an issue that's blocked, you've only got certain issues you can move it to. So if you have a look at workflow, so we go to project settings and I go into workflow. I had to make some choices about what the workflow looks like. And if I click on the workflow at the moment, Lucene health check failed. I'll have to check out what that's going on there.
What failed?
The Lucene health check.
So can we have these as we want, or do we need you to add them?
I'm not entirely sure.
I think you have that.
I think you might have to ask me to add issue types because I'm administrator for the system, and I think I might need administrator access. But here's the workflow. So if you look at blocked, it currently has the only way out of blocked, if I can get that, is, oh wait, stop.
Do you have a way out of blocked?
Yes, it's just that it's the continue is the way out of blocked. It's just that the in progress is not showing me how to edit it. So when I edit, so at the moment, the only way out of blocked, go around the bottom. Yep. There we go. The only way out is continue. Yeah? And so you continue, you put it into progress, right? So once it's gone into block, you can't just immediately resolve it. You have to put it back in progress and then decide where it goes. Right? So you can see, I've added continue and sorted So if it's sorted, it goes in review. If it's continue, it goes into in progress. But then you can't just go straight into resolved or into reopen or anything like that. It's, yeah, so. But if you have a look at the text, you can see we can edit out if I publish that. You can also see these workflows as a text workflow. Where do I see that? Yes, workflow design won't work at this resolution. There is a text version of this. Okay, I can't see it there. But yeah, so if you guys are interested in having a blocked status as well, or
The status for us is basically if someone's reviewing the issue and finding some errors or something, you disagree or something like this, he moves the issue to blocked. So the other person or the editor sees, okay, we need to talk about or I need to fix something, and then we go back to progress or discuss with the reviewer.
right? So you'd actually like to add from in review to blocked.
Yeah.
Is one of the transitions that you see as being.
In that case, when does the drop down appear? I mean, where does it appear on the dashboard? In which state is still unclosed or?
Well, so I'll add.
It has its own status.
I'll add a transition from in review to blocked. And what do you want to call that transition?
Not accepted.
Right. Unacceptable or not accepted.
Not just move back to the progress. That's what it is.
Yeah.
Yeah.
So
Yeah.
in normal workflow, you either keep it in review until you discuss it and then goes back to in progress, or you push it back to in progress.
Yeah. You usually you do have blocked. Blocked is something that you can have, but that's usually when there's something specific that needs to happen, right? So you're waiting for an external thing to happen, or it's gone beyond you. It's no longer I'm no longer reviewing it. It's that it has to go to the product owner, or it's blocked because we have a technology issue, or there's like an issue that you say is blocking. Then you have to identify which resource is blocking that, right? So yeah, just not accepting the issue, like saying in review and saying, oh, it's not ready yet.
Yeah,
that would normally be a pushback.
Yeah, it usually goes back.
Yeah. So what you'd normally think of the blocked transition is like usually an external is usually what you think of as being blocked, because that's something your team can't resolve internally. So we could call it problem. Could be the transition name. If there is an external problem which prevents progress. And the screen associated with it is your default issue screen. And then I add that transition. So that added review back to problem, and now it's called problem. So if I publish that, and when we go back now, so I'm showing the internal workings of Jira. If we go to your backlog, and I say, hey, I've got this issue you gave to me. Oh, actually, if we go to current sprint, rather, sprint, I've got this adding new task to Jira. If I move it, I can't actually go straight from resolved. I can go to done, or just hit to do, right? Mm-hmm. So what I'm in is I'm actually in a state where I can go, well, I'll put it back into there. Okay, reopen issue. So I had thought I was done with it, but I've now reopened the issue. If I put it into blocked, just so we can go straight into blocked, and I go into this issue, you'll see that if I go in, one. Up here, I have continue or sorted, right? Because that's sorted was one of the names I'd given for it, right? If I put it into, if I click continue, it changes its state to being in progress. I could then go, let's see, so workflow, close issue resolve. So I think that moves it into resolved, and then I can reopen and close. So these, what gets determined here is by what transitions I put in my workflow, right? So I could reopen issue. You're getting lots of stuff going through your.
But suddenly you're stealing Mario's time.
Yeah. So now Mario gets to talk. But yeah, so if you guys are happy with me adding those, I'll add those and change your workflow. Do you want me to add those and change your workflow? Or are you happy with the workflow the way it is?
We can discuss it after.
Okay, we can discuss that now. Right.
Right. So one of the issues which came up today was the definition of done. So what is definition of done? How do you define it when something is done and you can close it? Have you discussed definition of done for your projects?
Doesn't break the bill.
Have you heard the term definition of done?
See, Rachel and I have a definition of done, particularly around has the vacuuming been done?
Doesn't the definition of done depend on what you're actually doing? I mean, if you just have a critical fix that you need to get out there as quickly as possible, the definition of done should be like it functions.
You see, it's a bit of a rabbit hole, isn't it?
Yeah.
What does it mean it functions?
Well, it's.
I'm saying it functions, you're saying no, it doesn't function, and then we have a problem, right?
It solves the exact problem that, like I said, it sort of depends. I mean, in some cases, you need to think about maintainability and all of that stuff, so that might factor into what the definition of done is. But at other times, the definition of done is basically it just solves the issue. As in, like, if you have a particular crash, for instance, that is like critical to the project. It just like if that's really critical, it might be just that the program doesn't crash anymore, and then whatever you need to do to get to that point, sort of like the hot fix is done, and then you might have like another issue which is do this readme.
Right, I can buy into that. I can buy into like a case with a critical fix, right? We have critical fix, and then this one has a particular definition of done. So it is kind of contextual, right? But do you really want to have a definition of done for every single issues you have in your backlog, saying, how you're gonna make your process smooth? If you every single time you have to negotiate, what does it mean that you've done your task? Like these guys had a number of issues, and it turned out that they were not done. They have to reopen them, right? So that's why we don't do that per issue. We do it in general. We have kind of an agreement of what it means to have done something, and then you have a defendable evidence that it has been done. And for a very unusual case, when you do have a critical fix, something unexpected, then you do this unexpected thing. But for the regular thing, how would you define that an issue is done and can be closed? So you have your sprint, you have 17 issues in your sprint. They will be closing as you move along. How do you decide that the issue can be closed?
It's merged into master. So that means it has gone through the review process.
Okay, so merged.
Then you're basically just postponing or you're sort of
merged with master. Before that, you're saying it had to be reviewed. So kind of code reviewed. Code review. What else?
Documented and tested.
Yeah. Doc tests. So yeah.
Make sure that it's in agreement with what we decided with the public owner at the beginning. So I don't know, maybe not for a standalone issue, but for an epic, for example, if we compare it to what we decided with the public owner, and make sure that it corresponds
Okay, so here we kind of splitting hair on the test, right? So what you're saying is that if something has been agreed with the product owner and the product owner says, yes, I consider it to be done, then you would consider it done. So it's like the official term is acceptance tests. So, you know, you test it whether the product owner accepts what you have. And then you have all your developer tests like unit tests or regression tests and so on here, right? So the tests are kind of a little bit more complicated. So you can have a part of the definition of done that it has been actually accepted by the product owner. Okay, so what you should do is you should sit with your team and define what does it mean, you know, effectively, what does it mean to be done, and when can you close an issue, right? And that's what these workflows are about. So the workflows are about that you tick those things, right? So if you have in progress, then maybe it has to go to review. So somebody else checks the code. Maybe it has to be reviewed and run the tests. So it was reviewed and the tests were passing. Then it goes into, it's merged. And then, you know, the documentation is ticked off. And then it kind of says, okay, and we can actually close it now, right? We pass through all those checks that we require for something to be done. And then we can tick it off, right? Some of those things are done by you as a initial developer who is working on an issue, but some are not. So for example, reviewing, usually it needs to be someone else looking at your code, right? It has to be a second person. Tests, we usually automate it. We go into Bamboo or Jenkins and we run the kind of automated tests. And if they are passing, then that means it's okay. We can merge, right? And after merging, what will happen? You know, some tests may fail. So we're not done yet, right? We actually have to fix all the merging problems. And then when this is done, we again wait for the automated tests to continuously check if everything is fine. And then we can close the issue, right? So what Simon was talking about is kind of defining what is your workflow and how you should organize your things. And it's not kind of an ad hoc thing. It depends on how you define your process. All right, so today we will talk a little bit about the strategies for testing and about testing. And I put the video tutorial from 2 years ago. It's part of it is on Android testing with JUnit for Java. So if you know none of your projects are in Java, but you can kind of learn a little bit about unit testing using that framework. And part of it is for Angular 2 at the time, or even Angular, yeah, I think it was Angular 2. And using Karma and Jasmine to do testing. There are some hints on integration tests as well. So I encourage you to check it out. I will spend some time on the lecture notes, but the lecture notes are quite big. It's like 90 slides, all right? So we don't have time to go through all of it. So I will kind of cherry pick some of the things and we will discuss them, but I do encourage you to check the lecture notes in the deck and kind of get an idea of how would you like to structure your process. So one thing that we already covered is this definition of done, which does include testing, right? So if you had an issue and you've achieved the definition of done, you close the issue and it shows up, it turns out that you have to reopen it because there are still some things which we overlooked. It could be the thing that your testing is not sufficiently detailed, that even though you've tested it, you kind of missed some of the things. So you may need to add some extra testing to the procedure, or you may need to include a different test data. So you kind of design the process slightly wrong. So to kind of understand it, we have to step back a little bit and look at the testing kind of from outside, like what is the testing for, and what are the levels of testing, and why we do testing in general. Okay, so what I will do is I will go to the lecture slides, and we will kind of yes, where is my mouse? Okay, will this work? Sort of. Okay, so why is testing important in general? Well, one thing is, yeah, we need it for definition of done, but what else? Why do we need to test software? Well, we producing artifacts that influence people's lives. We often don't think like that, and often we have computing systems which don't result in, you know, serious problems. Like if you have a game and there are some bugs in the game, then okay, maybe there is a bit of a jitter or a bit of a lag, you know, nothing really bad happens. But a lot of commercial systems are kind of influencing people's lives. So we have software everywhere. We have software in, you know, self-driving cars and the ABS brakes, in managing the grids, right? If someone miscalculated something, that results in some real-world effects that result potentially in casualties. So here is an example of the blackout, which was caused by, you know, software bug. Another example is, for many years, we didn't know that there is a problem with ozone because the software which was analyzing the data was just, you know, removing the values for Antarctica as there is something wrong with the sensors. So it was disregarding the outliers, and without those outliers, everything looked normal. But it turned out there is a giant, you know, ozone hole above Antarctica, and for many years we didn't know that, right? Because the software was just deciding, okay, whoever wrote it thought, okay, we can kind of disregard some of the outliers because the sensors might be misreading the data. And then there is a famous case with the radiation therapy, where the software was, you know, actually, you know, killing patients. So you can have serious effects if the software is not doing what it's supposed to do, or if it's not doing it correctly. So testing in general is quite a complex thing. You've been already exposed to testing through like unit testing for some of the bachelor projects and in the undergraduate studies, but you can look at testing from multiple perspectives, and it's so big that people actually specialize in it. You can be a full-time tester as a career path, typically that's not actually a bad career path. All right, so let's have a little bit look on what terms you already know. So review was mentioned. So inspection review. We can review the code by looking at the code, or we can review the issue by just trying it out, right? So if someone says, oh yeah, this dynamic search for the articles is working, and someone is reviewing it, they will kind of fire up the system and try it out, right? They can kind of try the system. You have black box testing and white box testing. Do you know what the difference is? Have you heard those terms? So what's the difference?
I think that black box testing is like you enter some data, you don't know what happens in between. You look at the out, and you compare it to what you're supposed to have theoretically.
Yeah, that's right. So with the black box testing, you treat the system as a black box. You don't try to understand how it is constructed and how it works internally. You just give it some inputs and expect some certain outputs to happen, right? So you're testing it by feeding it with some data and seeing what reactions you get. And you don't know internally how the system works. With white box testing, you know the internals of the system, so you can write tests which monitor exactly the execution of the given functionality, right? So, for example, if you testing, Google search, you have a search box, you put a query, and then you check the articles which comes back that they actually match the query, right? That's the black box testing. You don't actually understand how the search works. You just see if the results are kind of relevant, right? But if you're doing white box testing, you know exactly what happens. So you know how the query is decomposed into components, so you can test that part. Then you know how the decomposed query is kind of issued into the corpora of the documents, into the data set that they have, how this data set is kind of narrowed down to a resulting answer, and how it is ordered, and then how it is presented to the user. So you can test at each step that this sub-step is executed correctly. So that's why we sometimes call it structural testing, because we look at the structure of how the problem is being solved and how the workings, the internal workings operate. And then if something doesn't work, you can pinpoint exactly at which step something was broken. Whereas with the black box testing, if something is not working, you just know, okay, this black box is not working the way it should. But I don't know exactly why inside it doesn't work the way it should, right? All right, so this is kind of a perspective on testing. We have we can look at tests at different level. So if we start looking at the testing framework from the developer's point of view, and the lowest level of abstraction, we have unit tests. So when you write your method, or if you write your class, you have certain requirements that this class or this unit of code needs to fulfill, and then you can write tests against that. So let's say I'm writing a factorial function, then I know for a given input, I should expect the factorial of that input, right? That's my test case. And that would be, I'm testing this, very low-level functionality. Then, if we move a little bit up the stack, if I have multiple classes, multiple objects interacting with each other, or if I have my module interacting with PMS module, I have something called integration testing, right? So I'm not testing something in isolation, I'm testing multiple things at the same time. And then we move even further up, and we're not only testing modules, we're testing entire systems. We're testing entire subsystems of our solution, in which case we have even more moving parts. And then at the end, we have these acceptance tests, which are basically tests to verify that the product owner is happy of what he or she gets. So acceptance tests are like fulfillment of the user stories that the system actually delivers the value, right? So if we have a user story saying, for example, me as a new user can register with the system using Facebook credentials, then an acceptance test would be checking if that story is fulfilled in the system, right? It is, so the boundaries between those different levels is a little bit blurred. You kind of can't really clearly isolate one from the other. So, acceptance tests are in a sense system tests, right? Because we make sure that the system actually fulfills a particular requirement. It's just that we added a product owner here. Sometimes system tests work. So the system is fulfilling all the system test requirements, but none of that is on the list of the product owner. Then, the acceptance test would fail, right? Even though the system tests succeed. And that's why we kind of need all of them. We cannot just focus on unit testing and think, okay, that's all that we ever need for testing software. We kind of need all of them. But we don't run them at the same time, and we don't write them for the same purpose. We write acceptance tests to make sure that we delivering the value to the customer, to the product owner, but we're using those three to make sure that the technical integrity of the system is fulfilled, right? and the product owner or the customer doesn't need to understand sometimes the internal testing. They need to understand the test on this level. Okay, so we will discuss it a little bit more in a minute. We also can do something which is called non-functional testing. So non-functional testing is when we test the system from the perspective of not the functionality of the system, but from some other angle, like for example, from the performance. Sometimes they are kind of related. So we may have, product owner may say, whatever you do, the search query in Google cannot take more than 2 seconds, right? In which case, some of the performance testing will become part of the, functional testing. But typically, we do that kind of in isolation. So we say, I don't care if the system actually works correctly. What I care is how fast it works, right? I'm not checking whether the product owner is happy with the system or whether the system, works as expected. What I'm measuring is, the performance or how much load the system can deal with, right? So those kind of non-functional aspects are kind of isolated out, and usually they are dealt separately. So let's look a little bit into the various testing perspectives. So in general, we kind of the overreaching goal is to increase the software quality, right? So we have here software quality assurance, which is that we want to develop the system which fulfills the needs of users and organizations. And it's not just about fixing bugs. It's not just about unit tests. It's about the kind of the proper life cycle and the software development process in general. So how can we achieve that? So we have a number of metrics that we can use to distinguish high quality software or from low quality software, right? So the first one is correct. So the system is, satisfying the expected requirements. Yeah, it's pretty obvious. The second one is about UI or user experience, that it's, okay, the system is correct, but it's so unusable that nobody's using it, right? So it's about how easy it is to use that correct functionality. Then we have how easy it is to maintain the system, to kind of continue with the software development lifecycle. How much effort do we need to put to modify the system? So maybe we, this is a trade-off between sometimes between the time of delivery of that particular feature versus the time of delivery of the next 10 features, right? And then we have 4 more. So we have performance, we've already discussed that. We have testability. So as we kind of continue discussing how we write the tests and how the tests are structured, you will notice that you actually have to make, again, trade-offs between your current design or current architecture versus an architecture which allows you to easily test your system, right? So it's usually easier to write a kind of a monolith functionality, which is kind of tightly integrated, and it's usually more compact and kind of easier to express, but it's much harder to test. Because for unit testing, for example, you need to have the ability to isolate kind of units of functionality that you can test it in isolation. So if I have a particular, class or object, and it kind of lives, in combination with other objects or functions in my system, when I'm testing this thing, I have to make sure that I isolate it from the rest of the system. And what I need to do is I have to have kind of a mocks or some pretended instantiations of everything else. So then I can only test this functionality, but nothing else. right? In a tightly coupled system, in a system that is not really easily testable, that's not the case. You have, calls being kind of made to objects kind of internally, and it's really difficult for you to isolate it. You can, for example, ask yourself, how easy would it be to test my system if I were to use a test database instead of a real database? Or how difficult would it be to test my system if I were using a fake REST API, not the real one, right? And then you will notice that, oh, maybe it's not that easy. Maybe actually I have it so tightly coupled that my REST API and the database are kind of linked so much that if I want to test something in isolation, it may not be even possible, right? And then you have to decouple it. You have to think of your architecture in such a way that you can isolate the components and test them in isolation. So you don't rely on the particular part of the system for unit test studies. Then we have reliability and reusability. So those are kind of metrics which we pay attention, but for this discussion, I want mostly to focus on the testability, right? Because we want to have a well-designed strategy for building and writing the tests. Right, so verification versus validation. Do you know the difference? What is verification and what is validation? What do you think? Without looking at the slides. Okay. So verification is to make sure that the system does what it's supposed to do according to the specification. And the validation is that the system does what the users or product owner wants, right? So it highlights that there may be a mismatch, right? So we often have some issues. There should be a funny cartoon. Yeah, you probably know that one. There is a communication failure at different stages of the project development, right? So you may have, what the customer really wanted, and how, different people at different stages misinterpreted it. So verification is to make sure that whatever was in the spec is actually executed. So it's sort of like there are no bugs in a sense. But validation is we have to make sure that we're actually delivering the value to the customer or to the product owner, and we're building the right thing, right? We can build a thing right, but it might not be the right thing, right? So that's the point here. All right, and how we get there? Well, there is only one way to get there. So, it's reviews and testing. We will focus on testing, but, a review is another technique which is used to make sure that we are building the thing right and building the right thing. All right. We can say, so that's the verification, and we may have some unforeseen circumstances. And we have to make sure that the system will kind of handle them properly, right? Sometimes, for example, when you are writing a game, the last thing you want is for the game to crash, right? So if you skip a frame, or if something is not quite right, but the game continues to operate, if you have some jitter or if you have some lag, users will kind of accept that. It will be okay. I mean, it's better if it doesn't happen, but it's acceptable. But if your system completely crashes and you have, a blue screen of death type of thing, that's the situation that you don't want to have in your game, right? So you can have some trade-offs, and you may handle some internal problems gracefully, saying, well, okay, I have null pointer or something, but then what? Then I just skip the frame. I will kind of recalculate things again, or something like this. You can kind of decide about the trade-offs. a lot of it kind of depends on the domain, right? So if you are, you know, writing real-time software for cars or for planes, usually the requirement is to be kind of you cannot be delayed too much. You can trade the accuracy or for the delay, but you cannot or you cannot crash neither, right? All right, one more thing. You know, testing will kind of demonstrate, will kind of help you to find out problems that you have in your software or in your design, but it will not prove absence of problems, right? So it is basically an odds game, like you writing tests to make the odds in your favor that there is less chance of your program to misbehave or to crash, because you know you've already discovered all the easy things that could have been discovered. So what is the technique to prove that programs do not have bugs? Can we do that? Can we prove that a particular program doesn't have bugs?
And doesn't that also depend on sort of like what's the context and defining sort of the bugs? I mean, if you like do, is it a bug if something just randomly happens within your computers and just like the old funny cosmic rays?
Yeah, good point.
That's not necessarily something that's sort of like wrong with your product directly.
Yeah.
So that's sort of
That's
be
right.
quite hard to.
That's right. So let's make it simpler before we get there and say we have a kind of particular spec. So we've properly defined what the function or program should do, and then we have a particular implementation, and we are running the implementation on a hardware which we assume will not fail. There are no cosmic rays, right? So in this situation, can we prove that the implementation is actually meeting the spec? Yeah?
That it's meeting the specs, we can prove with tests, for example, unit tests or system tests, like acceptance tests. Every requirement the product owner gave us, we have a test for, and even some edge cases.
Yeah. Yeah. So we can do this. We can do this link for some well-defined spec and some well-defined scope, but it is really difficult and it doesn't scale to complex systems. So there are formal methods which allow you to do this kind of mapping, but first of all, they only work for limited scope, and second of all, they don't take into account the problems that potentially I have with my spec, as he pointed out. I mean, the spec might be just wrong. We may have, the spec misaligned with the acceptance test, for example. And as PMS said, we never really have unfailable, hardware. We have human errors and we have network errors. We have, a lot of randomness in the real world. And this kind of formal verification methods are useful. We do use them for some of the communication protocols on, in the space shuttles. We have some modules which has been properly verified that they actually work. Carl, the researcher who works with Vic, he was writing some software for the jet planes, and it was kind of to do with navigation. And he had a problem because if let's say you have kind of like a car navigation in a jet plane, right? So that you have a dot which shows you where you are, right? And then you can kind of zoom in and zoom out. So if you zoom out, you have kind of larger scale, but if you zoom in, you kind of on a smaller scale, right? And he had a problem that if you zoom in too closely, the plane will kind of fly off the screen, right? So the dot will not be on the screen. And if that happens, then he would have some division by 0 or something happening, right? So he actually had to prove that if you flew off the scale and the dot is not on the screen, you will not need to show the dot on the screen because the dot is off the screen. And that will never happen, that you will have to draw the dot on the screen, right? It's kind of trivial in a sense, but if you formally prove that, that means this particular error will never happen because it's kind of by the logic of the design, right? But the tests didn't know that. So like the actual testing framework would pinpoint that, okay, if these conditions happen, that there would be a problem, right? So sometimes formal verification methods are used for software, but in general, they are quite limited. Right. So yeah, so that's the first one. Is you all do that. I do that, right? I wrote some functionality, like, you know, you set up your loopback, you go to the Explorer and you fiddle. Oh yeah, does it have those endpoints? Yes, it does. So does it do this? It does, right? So you are checking whether it works or not, kind of by manual visual inspection, but you can kind of formalize it, right? And in a lot of companies, it is formalized, and it was even more so before the automation. So now we have a lot of tools which automate things for us, but it used to be you get like a paper sheet with lines of what you need to do and tick boxes, right? So then you kind of go and you testing or analyzing something, and you know, ticking boxes like, can I log in? Tick. Can I do this? Tick. Does it have this button? Tick, right? And you basically have like a procedure, like an algorithm that you use for a human operator to test something, right? And we kind of do that. But for the sake of argument, we usually don't do formal inspection process in the Agile team. We kind of try to automate the inspection process and give it to the software. So even if you need to kind of click on things and so on, we try to formally specify it in such a way that the bot can do it for us, right? Automation is the king here. All right. So yeah. Yeah, so if we're using it for the code quality and someone else needs to inspect your code, then, you know, by definition, you're trying to write readable code because you know someone else needs to check that your code actually does what it's supposed to do. It's good, but it's quite costly. It's manual process. So we talked about the black box testing already, so I will skip the slide. You can read it later. What we will do is we focus a little bit on equivalence testing. So when we do black box testing, like let's say we have some black box and we want to make sure that it does what it's supposed to do, right? But you know, as with any function or any kind of system, there is like infinite amount of inputs you can give it, an infinite amount of outputs it will produce, right? So, but you don't have infinite time to feed it with infinite sequences, right? You can only test it for a while, right? So what would you do? Well, you need to think what are the kind of classes of inputs that the system deals with and kind of poke it with examples from each of those classes, right? The basic idea is that you kind of try to understand of what this partitioning is like, and then you come up with one or two examples from each of the class, so then you get a kind of a general feel that you didn't miss anything, right? So each partition makes the input, from the input makes the program behave in a certain way. Two tests from the same partition, they will reveal likely the same bug. And there is limited point of you poking from the same partition over and over again and skipping another partition, because it's more likely that if there is a bug, it is in the partition that you haven't tested, not in some nuance around the partition that you're testing. So if we pick one member from each partition, then we have a kind of a good chance of finding the problems, right? So, for example, so we have a system, and the lecturer or student administrator enters a grade. The grade needs to be from 0 to 100. Somebody wrote that functionality. What are the partitions? How would you partition the tests? So would you have just one partition? Would you have 2, 3, 4, or 5? What do you think? So who thinks? Yeah, give me some examples. So how would you partition the testing for that particular functionality? Yeah?
-1.
Yeah.
101.
Yeah.
Characters and something within the middle, I guess.
So -1, 101, and something between 0 and 100.
I like characters 8 to 7.
Sorry?
Some kind of text.
And
Floating
strings.
text.
Yeah.
And also floats.
And floats. So we have 1, 2, 3, 4, 5. Right? Any other suggestions?
None. Like no number.
Strings we have. Yeah.
Nothing.
Empty? Yeah. It's kind of it's a special case of strings, right? Very good. You can go a little bit further as you're suggesting, like go with empty, which is like a special case of, say, strings. You could also test border conditions. You could test 0 specifically and 100 specifically, right? The boundaries, because sometimes weird behavior happens on the boundaries, right? But that's pretty good. Like that's how you would design the partitions, and then just picking 1 or 2 examples from each kind of gives you the coverage, right? Yeah.
Depending on language, would you also add like, for instance, if you're working with PHP or something, you could try to add like an SQL injection, like test for something like that, or
that's right. So you would need to sanitize your input somehow and kind of test for that too. Yeah. Perfect. So this is pretty straightforward, right?
But you could say it's a 2-level testing. So first the testing is write that type, and it's int, then you don't have to worry about loads or SQL injection or anything. It's just an int. Then you are really
then you're really in that bracket. Yes, exactly. All right. So white box testing. So with white box, we can peek inside the system and kind of understand a little bit more of inner workings of the system. So like as Runa said, like we can, if it is PHP and we identify the test, we can only do some aspects of testing because we know internally how it is handled, right? So if we know that the data is sanitized and we only pass into the actual function, we don't need to test for some other things. On the function level, we may need to test for the other things on a kind of more module level, right? So if we know the internals of what is happening, we have a very useful metric which is called test coverage. So in your own words, what do you consider a test coverage? What do you think? All right, so let me show you. We have been.
To say what the universal.
What's that?
It's probably easy to say what the universal covered tests.
Yeah. So let me do this. So if I change this. Okay. Let's see if it will work. You see my screen? Yeah. Okay. So if I go to so we have the course for the second year for cloud computing, and we wrote a simple student kind of API where you have you can post a student into the kind of in-memory database, and you can interrogate the in-memory database to get you JSON back. So it's kind of a very simple REST API which handles kind of student queries. So you can get. So if I run it, so if I say. I actually. So if I run it, then if I go to a browser, yes, and ask for all the students in the database, I will get like an empty array of JSON objects, which because I haven't got any students yet. And then if I post something to that URL, I get something back, right? So now if I have system like this, I can write tests, and we actually wrote tests for the API. So we have a number of tests here, and let me just comment out the post tests and save it. And then if I go and say go test, it will run all the tests. Oh, yes. So in Go, if you are importing something that you're not using, and because I commented out part of the code, it's actually a compilation error. So I have to comment out IOUTs and strings. So let's say I'm not using this, and I'm not using this. Right. So now if I run the tests, it says, okay, all the tests pass. Right. I can look a little bit inside and see what tests are actually running. So I see, okay, I have the REST handler for something that like we haven't implemented delete and list and so on, some other verbs for the REST API. So we're testing if the API responds correctly with not implemented. And then we can pass malformed URLs and blah, 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 right? But I don't actually know how much I cover with my tests, right? So what I can do is I can hold tests with the flag, and then it will run, and it will tell me your coverage is almost 52% of statements. What does it mean? Well, let's have a look. If I open my IntelliJ IDEA and I open this project, I can actually visually see which lines of my source code are touched by the tests, right? So if I open this project, if I run the tests, right? So I will rerun the tests again. So it says, okay, almost 52%. It shows me all the tests which I am running. And what I can do is I can go and say, okay, show me the coverage data, and take this file which I've just done. And I see that I have a file called main, and I have 0 coverage there. So I have, because of the screen resolution, it's a little bit tricky to navigate. Red means, do you see the colors? No. All right, so that's not too good then.
You seriously need something to cover the windows on this side of the building as well.
Yeah. Anyway, so on my left side of that editor, I have red and green tabs, like lines, and they highlight me which code is being used in tests and which isn't, right? So because this is pretty useless on the screen, let me try something else. Let me do so which browser. You can also view this data in the browser, but I've been using the IDE. So yeah, okay. So I need to do this. So if we go back here and I run, oops. If I run that, I will actually have green for the code that my tests are touching. Now you see the difference, right? And if I go to main, I have 0 coverage. So I have a main method, which is just instantiating the in-memory database and plugging in some handlers. And I have a hello world kind of handler, which I'm not testing, right? So that's why main is 0 coverage. And students, everything is tested. And in the API, I have everything tested apart from the post, right? I have part of the code which handles the post requests, and I can clearly see this part is not tested. The get part and the not implemented errors are kind of tested. So if I go back to my tests and I will remove the comments for the final tests. And save that. And if I rerun the tests again, now my metric jumped to 75%, right? Most of my functionality is now tested. The only thing which is not tested is the hello world handler, which I have in main, and the wiring of the handlers in the main function. But if I go to the I will have to regenerate the. So let's regenerate. And this is called cover profile. Cover profile is this. So if I regenerate it and open it, I will now see that my student API is 100% covered, and the the types are also 100% covered. So it kind of allows me to check how well my unit tests are covering the space of the tests. So then I can improve my test designs so I cover more aspects of my implementation, right? And it's super useful. Most languages have it. Go has it kind of built in, so you don't need any additional tools to have it working. But most programming languages allow you to do that and estimate this test coverage metric, right? So what do you think would be a useful, desirable metric? Like, can you achieve 100%? Or is it worth to achieve 100%? How much work it would be to achieve 100%?
I would say once you're starting to close in 100%, it's not really productive anymore.
Exactly. So like in that simple example I showed you, testing that remaining 25% for me is actually not useful anymore. First of all, the hello world functionality is actually there just for a demo purpose. We don't really use it. And then the wiring in the main function, to really test that, I would have to properly do integration tests. It's not part of the kind of unit testing that makes sense to test, right? I could refactor it and could squeeze that in, but it doesn't make sense. So it kind of depends a little bit on the system, right? And the metric itself is actually less useful than this code coloring I showed you, right? Because if you look at your source code and you see kind of important piece of functionality which is red, still not tested, then you probably should write a test addressing that piece of functionality, right? The metric itself is not giving you that information. It's the actual coloring and the information of which part of your source code, which if statements or which kind of control flow are being executed while your tests are running. That's the kind of useful information. All right, so should you do white box testing or black box testing? Which one is better? Or which one is more preferable? They're kind of complementary in a sense, right? So the white box testing is more from the point of verification. It's like what the spec says and what the implementation does. It checks that part, right? But it doesn't really help you with validation, right? Validation is usually something coming from a product owner or from the user who often doesn't know what's inside, right? So it's not like one is better than the other or we only do one. We tend to do more of this because we're using tools and kind of unit tests and regression tests, but you kind of need both to have a robust and correct implementation. By the way, I'm using a term regression tests and unit tests, sometimes together. So what is the regression testing? Yeah?
Regression test is like when you update something, you don't break some of the existing behavior.
Exactly. So the beauty of automation and beauty of unit testing is that every single time you need to merge or need to commit something to a repo, you can run all those tests and make sure that nothing is broken, that the new functionality, the new changes that you're doing to your code do not bring kind of havoc into the existing functionality, right? So part of the definition of done is to have tests not only passing, but to have tests for what you've just created, right? So if you're adding a new module, if you're creating new classes or new functions, you should write functions that make sure those new pieces of code that you've added work correctly, right? And then if I'm adding kind of a new stuff into the project, and I've added my code together with my tests, and the tests pass, and after me, PMS is adding some of his functionality, and then he added his code and his tests, and now my tests fail, maybe he just broke something, some dependencies, right? We can check that. We can check, who to blame. Is it his functionality breaking my old stuff that's supposed to work like this because I have tests and I have a contract of what my, behavior should be? Or is it that maybe I'm missing something? Maybe I did something wrong. I mean, it is possible that you write wrong tests, right? You write unit tests, they pass, but they might be incorrect. It did happen to me, and it will happen to you too, yeah?
I think you make as many bugs in the testing code as in your original code.
Exactly, I mean, your rate.
Over time, you fix all the bugs in the testing code as well. So.
Exactly. So your rate of introducing bugs is the same, whether you're writing code or tests. So, but there are two strategies. So one strategy is that you write very small tests. You try to really make them very simple and very straightforward. So the chances of you introducing bugs in tests is quite low. The other one is that, as we were just discussing, your tests are being run over and over, and then there is multiple eyeballs and multiple people kind of making sure that the tests are actually correct, much more so than the functionality of the code. So tests tend to be, they have to be bug-free in a sense. All right, so we have another example. We will skip it. This is for defining a boundary test for a program that checks if a student qualifies for a foreign exchange program. So we basically have a little sheet that we can use to test if the piece of software works correctly and identify those kind of test cases that we have to automate. All right, we discussed the levels of testing already. So we talked about unit testing and then module testing. So unit tests, isolation, mocking, you use mocking frameworks for that. You use unit testing frameworks for that. Modules, you kind of make a little bit more complicated. You probably testing more than one isolated unit. So this is usually kind of component testing. As I said, those boundaries are kind of, not super well defined. There is a bit of an overlap, but you technically can, you know that you're doing integration testing if you have many moving parts working together, right? Component testing, you're testing isolated components. Integration testing, you're testing components together, multiple components together. And then it kind of scales up to proper system testing and then acceptance testing. This is usually a black box. You don't you don't care how certain things happen. You just make sure that the expected outcomes happen. So unit testing. Testing the smallest individually executable code. It should be fast, performed by every single developer. You should usually automate it that before your commit gets accepted by the repository, all the tests pass. If some of the tests fail, your code is not merged or not pushed to the repository, right? So before you push code to the repo, usually you run your unit tests to make sure that everything is still fine. In a lot of teams, there is a rule that you don't keep on a server stuff that doesn't compile. But sometimes you also have a rule that you don't push something that doesn't break tests, right? You have to branch it. If you have something that breaks tests, that means something needs work. So, create a branch and let's work on it. But keep the master branch clean and tests always pass. So again, it's up to you to decide how you structure your work, but that's usually the way to do it. And the unit test, as I said, you run it multiple times per hour. You often run it before you push to the server. Integration tests are a little bit more involved. They combine multiple components together, they will detect, interface mismatch, something you kind of agreed, but this JSON structure is slightly different than this because you've used a different key for a certain value, and then this module works fine, this module works fine, but they don't talk to each other because there is some miscommunication happening. So this we don't run all the time. We usually run it when we make some sort of larger merges or when we merge branches together to the master. So they need to spawn a little bit more underlying functionality, and they are a little bit more costly to run. So we usually use something called like continuous integration server, like Jenkins, to run those for us, every night. It runs all the unit tests and all the integration tests, and in the morning you have reports like, oh yeah, PMS committed something, the individual tests were passing, but the regression tests failed. There is some sort of communication problem, right? And we have two terms which you may see in the literature. It's a top-down and bottom-up. So top-down uses stubs. So you have you have some sort of logic that needs to operate on the components, but you're making the components kind of mock, and then you're driving the behavior from the top down, right? Or you're using the other approach. So in the top down, you're actually testing the top functionality. The bottom layer is mocked, and from bottom up, you've implemented the bottom layer, but you are using the test to kind of drive the bottom components. And often you combine both, right? So you often do a little bit of that and a little bit of that to get the kind of the integration test done correctly. And here is it kind of depends of what you're mocking and what you're driving. So in a test, you usually have to orchestrate something, and then you also, because you're not instantiating everything, you're kind of mocking some parts of the system, right? So in a particular situation, you either mocking the bottom and kind of orchestrating from the top, or you're doing the reverse. So this is more about this, like how you're testing the components. And then the final level, I mean, it's not the final, it's the final technical level, because you have the acceptance test. After that is the system testing. So usually we call it end-to-end testing or system testing, where you actually instantiate the entire system and you make sure that the functionality is working correctly. Again, we kind of more in a white, in the black box testing here, but you may be using some knowledge about the system if you have to. Usually when you're doing that, we also do some performance testing too, right? So last night I was doing some testing on how much throughput this particular student API can handle, but you have to ask some REST API and get the results. So in a sense, you're doing some sort of system level testing, even though I was doing performance testing, right? And then the final one is the acceptance testing. In the recent years, I mean recent in a sense, maybe like 10 years or so, there was a kind of a strong movement to automate acceptance tests as well. So there was a kind of development of languages which kind of read a little bit like a human spec, where you write like little scenarios, little user stories, which then can be automatically tested against the system in kind of end-to-end fashion. So I think it started with Cucumber, with Ruby on Rails, and it kind of gained popularity. So there are languages for Java and for JavaScript and so on, which allow you to develop kind of high-level scripts which a non-technical person can read, and they kind of read like sentences in natural English language, but they are actually specs for the test cases, and then those specs run in the end-to-end fashion and correctly finish or not, right? And you can treat them as sort of testing against user stories, and it is kind of an automation of acceptance tests, right? Because otherwise you'd have to go to a product owner or a customer and say, okay, here is the system, make sure that it does what we agreed upon. And yeah, this kind of a human type interactions are a little bit error prone. So it's better to have something more formal. So you'll find some languages which allow you to do that. Yeah, we have extreme programming, which you guys know, you're using agile methods. And then you have frameworks for unit testing. So as I said, I had an entire lecture recorded on using JUnit on Android and using Karma and Jasmine for JavaScript. But yeah, we're running out of time here. So I encourage you to check the video or check the framework that suits your language, right? If you're doing something with C++, there are C++ unit testing frameworks, and if you're doing something with JavaScript, you get Jasmine, or there are many others. And they offer you unit testing, but they also can express this kind of readable formats where you can test kind of acceptance level as well. So yeah, so unit tests, usually you have a suite. Usually you have like a setup method which runs before every kind of test case is executed, and kind of a tear down method which is cleaning up after the test case. So for example, in my case, I have an empty database every time I'm instantiating the calls. So then I have predictable behavior. So if I have an empty database, then when I ask for all the students, I get an empty array. But I can have another test which says, okay, I have now 2 students. If I ask for all the students, I should get back an array with 2 students, right? So I have to like prepare something, do the test, and then check if the test succeeded or not, and then tear it down. So that's usually how the frameworks work. All of them are very similar, and once you know one, it is easy to transfer to any other one. The Go testing framework doesn't have a setup and tear down methods. You have to do it for each kind of a test case that you're writing, and the test cases are just functions. So you just write a function which starts with test. There's kind of usually some naming convention, and then you have some checks to evaluate what post conditions are. So here is a simple example. Then you have those annotations. So, before and after, those are the setup and tear down methods, which I told you about. And test is the actual test case, right? And then you have those assertions. So usually in your test case, you're kind of doing some behavior, and then at the end, you're checking if certain post conditions are met. So if I've added new student to my REST via my REST API, I expect my in-memory database to be 1 more than before, right? If I deleted a student, 1 less. If I've added Tom, I would like to be able to find Tom. It should be in the database. So I can kind of check all those assertions after my logic. And then if any of those assertions fails, the test kind of blows up. The test tells you, okay, that wasn't fulfilled. All right, so okay, so final question, very simple. So your input takes an integer. Which of the following represent the equivalent partitioning? What would be your answer? So if you have a function which takes an integer as a parameter, and you want to have some simple partitioning for your test, what would you use?
I guess B, seeing as that covers the most.
Yeah. So B is kind of the obvious choice because it covers the negative, 0, and positive integers, right? It's sort of the easiest partitioning of all the infinite integer space that you can make. Is it covering everything? No, it's not. It just covers, negative, positive, and 0. 0 is usually, again, kind of a special case, but so is 1, right? If I were to test this function, I would be kind of afraid that that's not enough. I probably should test it with some bigger numbers too. You can also test it with the limits. You can take the min int and max int as well, right? So I would probably end up with 5 examples, but as a partitioning, it's kind of good enough. All right, so I will stop here. As I said, the deck has 91 slides. We are at number 35. So, there's still a couple of hours to go. If you have any questions, do not hesitate to ask. One of the common questions is, people understand the unit testing, they understand regression testing, they understand everything. And then yet they developing a game or developing a system, and they don't write any tests, right? And they do that because the trivial tests feel too trivial. Like, why would I test those trivial things? I mean, they're obviously correct because I can, I just wrote them and I see they are correct. And the more complex things, they don't know how to test. Like, how would I test that? And that's what I was mentioning before, this testability, like designing for testing is actually it's a little bit of extra work you have to put in, but then you will have benefits of having those automated tests. And I do encourage you to have tests as part of the definition of done, not test passing, tests as added to the code base. So if you wrote a new class or if you added new functionality, tests have to be included. You have to write tests for that functionality that you're adding, right? The benefits are enormous because you have the ability to do the regression tests every time the merge happens, and also guard against some code modifications later. So when the new features are introduced, they often break something that was working before, and then you say, it used to work, why it doesn't work now? And it's really hard to debug that, right? If this original functionality was done, 2 months ago. Yeah, Runa?
If you are in a REST API or any web-based app, it's not that difficult to write the kind of system or acceptance tests. You say, okay, given this input, you're supposed to get this feedback, and with the frameworks you have today, it's not that hard to language to write those tests. It takes some time to learn, but once you learn the framework, it's pretty easy to write the tests.
Yeah. Yeah, so maybe I will go like 2 minutes over time, and I will tell you about one more thing. So there is one concept which we haven't covered yet. Yes. So test-driven development is the concept which kind of some people hate and some people love. And what it means is that you make tests before you write the functionality. Have you ever done that? Have you ever wrote a test before you had the functionality? So what do you think? Was it good to do it?
It's particular when you do it for the first time because you're really not used to that, and it's hard at the beginning to get into it because you don't even know how to write the test and what to test. And yeah, but I think I wouldn't say it's good or it's bad.
Exactly. So it's not universal, right? But it has its place. And I often like to do that because it allows me to check the API that is not developed yet of how it would feel when I have to use it. So when you have a new class in mind, usually you start by saying, public class, blah, blah, blah. You write a bunch of methods with parameters, and then you start using it, and it's like, let's rename this to this, let's make it more consistent, don't pass this here, and so on, right? So when you start actually with a test, when you start using that API, it feels more natural to design the API because you're kind of doing it from the user perspective, right? You don't doing it kind of in a vacuum. So I quite like that, and also it forces me to kind of have tests, right? Writing tests is a little bit of an extra work that you have to do. So if you already have a working functionality, it's very tempting to move on to the next issue and to do the next feature instead of testing what is obviously already working, right? But yeah, so I mean, I have a mixture. I don't do it all the time, but sometimes I do that, and every time I do that, I never regret it. So, yep.
It kind of depends on whether you can actually understand the problem up front.
Yes.
I mean, for instance, checking if something is sorted or writing a sorting function, that's quite easy to write test first because you know exactly
what you expect back.
Yeah.
Yeah, exactly.
But if that sort of can vary, or you're not exactly sure, you're sort of still exploring the problem.
That's true.
Writing the test up front will just make it so that you'll start working, and then you figure out that no, this won't work at all, and then you have to rewrite all your tests again because obviously you have to write them first.
That's a very good point. So sometimes we code against something that is clearly defined, and then writing a test first is perfect. Sometimes we're quite not sure how it would feel. Do we need one class or two classes? And you just kind of explore. And when you're exploring the space, then writing tests first usually doesn't work. Yeah. Yep.
I like using this approach when I have a bug, for example. Then I write a test where the bug is failing the tests.
Yes.
And then I can go to function and modify the function until the test is real.
Exactly. So that's a very good comment, because that's what you all supposed to do, right? So if there is something that doesn't work, or if there is a bug, you should write a test which demonstrates that there is a bug and the test fails. And then you modify the code to make the test pass, right? And you end up with an extra test case in the system. Yeah?
To go back to my previous comment, the thing here is that that's absolutely right approach and needs to do if you have invested in setting up a test framework in the first case.
That's true.
There is an investment to be made in the first case, and I think you all should do that.
Yeah.
You should go set up a testing framework for your tools, for your applications, both at the unit level and at the more of the system level, and not necessarily do the test-driven approach, write tests first, but at least write some tests and know that you know the frameworks, and when you have a problem that you see is recurring,
you can use it. Yeah, it's already there.
Because if you don't invest in setting up the framework and you have a problem, you say, okay, no, let's not do it this time, and then you do it next time, or the next time, or the next time, or the next time. You never do it.
Yeah.
So get it up and running right away.
All right. So we're hoping you guys will set up testing frameworks and will do some tests as part of your development. Yeah.
Just wondering, technically, would it be? I mean, the ideal situation would basically be that you didn't have any unit tests; you only had system tests. But the reason that you have unit tests is that the system tests have so much overhead of running. Because you're always really just wondering whether or not you work in the context that you're supposed to work in.
True. It is.
I mean, obviously, that's the ideal. You never reach the place where you can, or it's probably like way too much work to get to that place. But wouldn't that be the ideal situation, that you only test like the whole thing integrated?
Yes, but you cannot really do that.
Yeah.
Because to get there, you have to have those scaffolding happening. And while you're building those scaffoldings, you have to make sure that this is correct, right? Because at the end of the day, you want all those system tests to pass, right? But if the system tests fail, how do you know what to fix? Yeah.
And also for reusability. I mean, it's for instance, if you think about the validation of user input data.
Yeah.
So that you can do at various levels in your code. Now, if you start using the lower parts, unit parts of your code in a different environment, you may not have the upper level validation. So you get all of a sudden you get other input than what you used to do. So
exactly.
It's good to test that each module, each unit works the way it's supposed to do, so it in different environments and still works.
Yeah, exactly. So I think the analogy of scaffolding is a good one. Like at the end of the day, you want a building to be solid. You don't need scaffolding to be solid, but you cannot get to a solid building without a solid scaffolding first, right? So that's why we have all the regression and unit tests to kind of build up to the system level tests. Yeah. Other questions? There are good frameworks for JavaScript. There are good frameworks for testing the REST API. Like REST API is a perfect case. You just write your kind of a poking agent and check, okay, is the data correct? Is the header correct? You know, for all your endpoints. If you're using something like loopback, you don't really test for the obvious things because loopback takes care of it. But you test, for example, for permissions. Like, can I ask loopback for this data even though I'm not logged in without the access key? Like, do I get my permissions correctly, you know, organized? Can I poke to the other lobby? Like, can I mess up with the other server because I know the, you know, I overlooked some key or something? So you can test a lot of security and kind of behavior. You don't test, okay, if I put stuff there with push, with post, can I get it with get, right? I mean, this is obviously working because they've already tested it. But you can test some things that are in your power to fix if it's not working, right? Yeah. And unit tests in general, they're kind of, every time I'm writing kind of new function or new thing, I'm wondering, can I test if it's working correctly? If I can, then I write a test. If it's, you know, if it's a class with some attributes, usually you don't test the attributes that they are there, like that, those kind of obvious things that are not worth testing. But the behavior-wise or kind of linking of different functionalities, that's definitely worth testing. Yeah.
Do you have any tips on testing a concurrent environment?
Right. So that is an entire lecture which we could spend on. The state of the art is to use structured logging. Right, so you try to use a logging framework which allows you to store contextual information with your entries in a hierarchical manner, so you can effectively filter it on the context, and you just use logging for concurrent debugging and concurrent testing. There are some frameworks which allow you to do some things, like Go has a built-in this race testing where it tries to slow down and speed up some of the Go routines that you have and observe if the outcomes are consistent. Every time it is not consistent, it will tell you, oh yeah, you have potentially race conditions somewhere, right? But those are far from solving the issue yet. Yeah. All right. So thank you very much.
Just before we're on,
Yeah.
yeah.
I have to leave, so we will continue.
Yeah, since they have to leave, just very short. If you look at the course description, it says that you should be capable of defining good test strategies. It doesn't say that we need to have lots of testing experience, but we need to have a good test strategy. So next time we meet, I expect we all expect all of you to have an idea and have a first decision on how you would like to have testing integrated in your project. So that means we're good if everybody had decided on testing framework and decided on what the intention is when it comes to unit testing or system level testing. And again, we are not requiring test-driven development. We are not requiring 80% test coverage, but we require that you have a clear idea and a vision and an intention for the test strategy and how you would like to do the testing. And as I was saying, if you don't set up the test framework now, it won't happen. So just get it started right away. Decide on the test framework, get it running, and start making some tests. And as we said, as you see issues coming up, you write tests for it. And for the critical parts of the system, you write tests, so you can do that. But agree within the teams on your strategy in terms of coverage, in terms of what type of testing you want to do, and how you want to organize, including possibly manual testing. Maybe before giving a demo, you agree that one of the team members is the one to test the functionality of the other team members. And so you have a plan for how this is, including the manual testing. Manual automated testing at various levels. Okay, and we'll see you in a couple of weeks.